Today, Lesson 6B, Review of Systems. We've spent 5 days dealing with solving systems of equations by graphing and the substitution method and the elimination method. And in the very last lesson, we hinted at this idea that sometimes systems also have no solution or infinite solutions. And all the same rules, if you want to think of them that way, apply to systems as they did with everything else that we've talked about this year. So, let's get started. Remember, when graphing, wherever the ordered pairs intersect, that is the solution. If we end up with parallel lines, that means they don't intersect, which means the lines have, or the equations of the lines have the same slope but different y-intercepts. That gives us no solution. And when we're graphing and we end up with the same line, in other words, the equations are equivalent to each other, the lines coincide, which gives us an infinite number of solutions. But here was a problem that I gave you in the very last lesson. This is how we ended the day with this one. And so I'm just going to go ahead and solve it for you because we did this one in class. But we ended up with the variables canceling out, which means that we ended up with a true statement, which of course, all year long, if the variables cancel out, we end up with a true statement. We end up with infinitely many solutions. So we also talked about this on that day. A reminder that if the variables cancel out, or they are eliminated, and we end up with a false statement that gives us no solution, like in that example, or if they are eliminated and we end up with a true statement that leads us to infinitely many solutions. So now we're going to do a little bit of practice of that. I would like you to solve this system by substitution, not elimination, substitution. And the only reason I'm making a point of that is I noticed that when I walked around during the warm-up today, even though I told you to answer 1A with substitution, some of you did it with elimination. In order to solve by substitution, you have to take one equation and solve it for a variable. It doesn't matter whether you take the first equation and solve it for x or for y, or the second equation and solve it for x or y. To me, it looks like it might be the easiest if we take the second equation and solve it for y. But some of you may disagree with that. All right, so let's take a look at this one. I am going to take the first equation and solve it for x. Why? Because I want to. There are many things that you could do. So I'm going to now substitute 2y minus 3 into the other equation for x, because that's what x is. And we end up with this. Now a little bit of simplifying and solving, and I end up with the variables, both variables being eliminated, and a false statement, and that of course means we end up with no solution. And if we ask you to prove that, you would have to prove it graphically. Algebraically would be very tough to do. All right, let's go to number 3. Solve this one using substitution. All right, so I am going to take the first equation and solve it for x, because for me that looks like that's the easiest thing to do. When I walked around, that is what most of you ended up doing. So I'm going to substitute 2y plus 2 into the other equation for x, and then solve. Both variables are eliminated, and we end up with a false statement, therefore no solution. If I were to ask you to prove this, you would have to prove it graphically. All right, let's go to number 4. Solve this one with substitution. All right, so we're already solved in the first equation for y, so we will substitute that in. Both variables are eliminated. We end up with a true statement. Obviously, that is infinitely many solutions. Now, this brings up a point. There was one problem on the last quiz where it was to solve by graphing. All right? And the answer to it was infinitely many solutions because you were supposed to end up with the same line. And I can remember, John got something different. And he said, yeah, but I plugged in the ordered pair and it worked. That's because any ordered pair that you plug in will work. Exactly. So that's where we have to be careful sometimes. And this is another one. My point in saying that is this. This kind of problem, you also would have to prove it graphically, because all ordered pairs will make a true statement. Okay? Let's go to number 5, this time by elimination. So in order to solve any system by elimination, you really should make sure that both are in standard form. The first one is in standard form, the second one is not, so I'm going to take the second equation, subtract 2x from both sides, and then I'm going to multiply the top equation by -2. If I do that, I don't have to do anything else. And so look what happens. X is eliminated. Y's eliminated. That means on the left-hand side, I'm left with 0. But on the right-hand side, I'm left with 2. That is a false statement. Therefore, no solution. All right, we are ending today with a lead-in to what's going to be happening the next 5 lessons. And that would be 5 days of taking systems, creating systems from word problems. So we're going to kind of work through this one together. A farmer saw some chickens and pigs in a field. He counted 30 heads and 84 legs. Determine exactly how many chickens and pigs he saw. Well, if you didn't know this, chickens have 2 legs and 1 head, and pigs have 4 legs and 1 head. All right, I'm going to give you about maybe 3 or 4 minutes to work on this with your shoulder partner. I want you to see if you can come up with a system of equations that you could use to solve this. And let's use, instead of using x and y, let's use c for chickens and p for pigs. Okay? You got about 3 or 4 minutes with your shoulder partner. All right, so we're using c for chickens, p for pigs. The first equation, which I'm calling total equation because I'm going to keep coming back to a total equation. A total equation is the total number of animals, or in this problem, the total number of heads, because each animal has 1 head. So I'm going with c plus p equals 30. I don't know how many chickens I have. I don't know how many pigs I have. All I know is that there are 30 of them altogether because there are 30 heads. And then I have the legs equation. A chicken has 2 legs, a pig has 4 legs, and once again, I don't know how many chickens there are or pigs, but I know if I take... Okay, well, it's going to have to wait because I'm teaching right now. Tell her I'll put them in Dropbox. Tell her she's now on the screencast as well. So if I take the number of chickens and multiply by 2, and if I take the number of pigs and multiply by 4, that will be 84. So I have my system. So I'm now going to take the top equation and multiply by -2 so that something is eliminated, which now gives me this. And then my c's are eliminated. I end up with 2p equals 12. So I have 12 pigs. And now I know that there are 30 animals altogether. So if I take that and subtract it from 30, I end up with 18 chickens. Now, the quick check. There are 30 heads altogether. You can see from 12 and 18 there are 30. If I take and now figure out the legs, pigs have 2 legs, so that's 24 legs there. Chickens have 4 legs, not...
You did it the wrong way again.
Oops, wrong way. 2 there, that's 36. And 4 there, that's 48. And that is 84 legs altogether. So that must be right. And that is it for today.